we have this is 50s, this is 30s. So we go one more time. 30s, 50s, same thing. We have E, P, A, then you can read it by yourself. Exit site, peptidal site, amino binding site. So what happened here is this guy gonna release. So this guy will release. Then in the middle, what's gonna be is where it goes here. So in the middle will be this guy. So that will become AA2, AA1, and MET. And then we have another one going to come in. That's maybe AA3. Okay, the same thing goes this way. Now, we want to talk about this. This chain gonna goes long and long, long and long. Is that right? That chain gonna become long and long. MET on the top, AA1, AA2, AA3. What does it rely on? This is already called a P site. Transpeptidal place. We need a transpeptidase. This is rely on 23S RNA transpeptidase can do transpeptidation. Then become a peptide chain, longer and longer, longer and longer. That's the procedure how they do it. If you don't understand about that, we have a picture here for you. I don't know whether I have here. I didn't encode it in here. We'll talk about those three sites. And this whole process here, we also rely on elongation factor 1, 2, and 3. We also rely on Hu, which is another factor, and we need a GTP to hydrolyze, become GDP, and with a phosphate. So this is a process for the elongation side. Okay, now we want to make sure it's a little bit complicated. We don't want to make it very easy. Okay, this is a cartoon movie. You can read about it, what it looks like. How about really happens here? What this really talks about? We want to talk about it from structure standpoint, so you can understand it. So we're going to talk about it. So we have this area, we're going to draw it. This is P side. This is A side. Okay? Let's talk about only P. Okay, we don't care about the E because it's going to release. So P side, let's just give you an example. I'll have a structure, which is A. This is H, OH, this is H. So you have H, this is O. So you go here, you have H, CH2. So you have a O, then you have a phosphate. So phosphates right here. Okay, I'm going to carry on tRNA. So I go here, which is C and C. This is 5 prime, and you go here. Variable bound, anticodon arm. That is tRNA. It's like that. The P side. Okay, so I'm going to carry on amino acids. What they're going to do? They usually happen here. And I'm not going to use the blue because the blue is not going to show up. So what we did here is COO, C, this will be R1. Sorry, now we do R2, H, NH. So you go here will be C, O, C. Let's say the first one MET, and you go H. This will be NH2. Okay. So I'm going to happen right here is the A side. Something going to come in. So something coming. Let's say I have a G. Let's say I have a G, H, H, OH. You have an H. Okay. O. This is H. CH2. I'm just to be a little bit easy. And the TIA. So this guy is there. And I will say this is amino acids. Let's go here, C, carbon dioxide group, go C. This will be all, this is R1, let's say. This is going to be R2, so this is H, this is NH2. So the A side going to come in, what they do? How they reacted. This guy going to attack him here. Going to attack him there. And this section will be released. This whole section later on will release, go to E acid side. Go, there will be go. There will be gone. And this guy goes here. And this whole thing will move to P side. So, what's the reaction right here looks like? I'm just going to move this one, go here, okay? Move this one, go here. This is R2. So you go here. This is R1, H, NH. Then you go C. Then you go C, MET, OH, and NH2. That is what it looks like. And remember, in your biochemistry, this is peptide bonds. Now you're going to ask me a question. When you see these cartoon movie and when we draw here, you know from top to the bottom. But here it is bottom to the top. So when you read about these, this has to be upside down. When you do this upside down, you will be understanding it. That's just connected with that. So that's why I said it is always important that you know this structure, because that 3' carbon is important. That actually carrying is amino acids, and that 5 carbon is carrying a phosphate connected to the 5' of a TIA. That's what it looks like. And then they go to the opposite direction. And the FNT is always on the top, and this forms 5' to 3'. That's always is a translation, what it happens generally. Okay, now the stop coding is always easy. Translation, how do you know it is stopped? When you see the stop codon, when you see the stop codon, when you see UAG, UGA, and the UAA, that means it's stopped. It's going to stop to do the translation. Now we know that for the eukaryotes, there is a modification after that. Is that right? That's what we talk about. So this is a very simple procedure we described. What's the precision for the translation, what happens here. And lots of the textbook will be talked about right here. And a little bit of difficulty to understand is this A side and the P side. But the key thing, if you know the structure, is always remember the MET at the beginning. R1 and R2 is go upside down direction. Now, when I was student, I have a question. I said, you said MET is the first one. Why it is the first one? My teacher does not give me the answer. This is, he said, you think about the eggs and the birds, which comes first. So the only answer will be, as long as the cell is survived, more or less it will have some MET which is left in the cell system, and that could be used to start the translation. And you also keep in mind the replication, transcription, and translation has to be coupled, have to be do all the time. And usually the speed is like a 2,000 BP base pair per second. It has to be circled very quick, otherwise the bacteria will be died. So we talk about this separately, but that happens almost in like 1 second to 5 seconds. Okay? So this is something we talked about. Okay, we left a little bit of time. So about 6 minutes, let's go over the amino acid, the side chain, and because that will be also the extra points of the exam. And we also will go over again more detail in the lab section of the Thursday. Okay, so let's talk about that. I'm always interested about these structures because when you do this structure, you will understand what's the story behind that instead of you just remember. So let's talk about that. So we have the 20 amino acids. 20 amino acids based on their charge. There is a first group which is called non-polar no charge. And I will say there is a one chemical, one amino acid is debatable. Okay, so we'll talk about that. So what are they? I always going to do all side chain. So let's draw this again. If you don't know about this, COOH, H, and O. So we're going to only talk about this all side chain. First one, H, glycine. Because of the H, so this is non-chiral. Second one, CH3, alanine. This is everybody knows these two. Okay, then go through a little bit complicated. CH2, CH3. Violin. Then you go. CH2, CH, CH3, CH3. What is this? Leucine. Then you go. CH3, CH, CH2, CH3. This is isoleucine. And then you go, the next one, we have to draw the whole thing because it's a circle. Okay? So CH2, 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 this is proline. There should be no question about all these. The first couple. Then we have one we talk about in the class, in the lab section. Do you remember it? What's that? We talk about the one in the class. What is this? Phenylalanine. Remember we talk about this in the lab? Phenylalanine deaminase test. Next one we also talk about this in the lab. This is the one a little bit difficult. If you don't know how to draw, we understand. Okay, so NH2 right here, CH2. What's this? Tryptophan. Okay, what's the next one? This one is debatable. This is serine. Oh, sorry, this is cysteine, sorry. The next one is cysteine. Because it starts to showing you the sulfide group. But a lot of the textbook for this guy into polar non-charge. But some textbook put this in non-polar no charge, that's cysteine. Okay, next one we just mentioned. CH3, CH2, CH3, S, CH2, CH2, that's methionine. Methionine. Okay, so this is the first group we'll finish. Non-polar, no charge. Then we go to second group is polar no charge. Polar no charge, the first one, CH2OH, serine. Then we have CH3OH, serine. Then you have CH2CNH2. This is asparagine. Then you have CH2, CH2, CNH2. This is glutamine. Do you like salt, glutamine? Glutamine salt, it's a very good, the sodium glutamine, it's a very good one to make soup. It's very, tasting very well, but don't eat that too much. So that's glutamine. Okay, we have another one we haven't talked about, is tyrosine. So you have a carbon group, OH, and CH2. This is tyrosine. Okay, finished here. Non-polar, no charge. Then we go charged one, which is polar charge. First of all, negatively charged. You have asparagine here. Very simple. You will have aspartic acid. So, is that right? This is aspartic acid. Then second one, glutamate. You have a glutamic acid. So CH2, CH2, this is glutamic acid. Okay, we left the three positive charge. First one, this is histidine. This one is a little bit difficult to draw because it's a 5 carbon, always difficult. So we have an NH plus right here, and we have NH right here. So it should be this one. Okay, then we have a lysine. Lysine is a very long CH2, 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 then NH3. And we call this is epsilon amino acids. Remember? The milk have a very large components of the lysine. So what happened is very easy to react with glucose or with reducing sugar, like lactose. It will have a Maillard reaction, become a yellow color. That's lysine. The last one, CH2, CH2, CH2. We have NHC, NH2 plus, and NH3. This is arginine. Okay, there is a one joke. You can remember this: histidine, lysine, and arginine. What do we call it? His or her lagers are basic. Did you understand this joke? Histidine, L, lysine, or arginine, basic. They are basic amino acids, positively charged. This is to make a joke for the undergraduates back in 1980s, wearing longer boots, hang around in the campus, did not study very well. That's why we say his or her lagers are basic. So you understand it very well. Is that right? Histidine, lysine, arginine are basic amino acid. That's giving you 1.5 extra points already. So there you go. I may be wrong on 1 or 2 chemicals, could be because I'm talking about almost an hour. So we'll be more refreshed talk about on Thursday morning. We go over it. Okay, +5 gene base. So that's what we have to do.